Part 7, The Law of Logical Induction. You are now invited to consider that important law of logical reasoning known as the Law of Logical Induction. This law represents the universal experience of human thought rationally applied and directed. The law of logical induction is expressed in the fifth of the 7 axioms of logical reasoning, which is as follows, v. The axiom of logical induction: what is discovered to be true of a great number of observed objects, things or individuals of a definite general class, is practically certain to be true of that general class as a whole. The characteristics assumed to be possessed in common by all the individual objects or things in a definite general class, constitute the accepted essential characteristics of that class as a whole. This fundamental principle of induction has been stated in many forms, among which are the following: what is true of the many, is true of the whole. That which belongs or does not belong to many things of the same kind, belongs or does not belong to all things of the same kind. Mill's statement of the principle of induction is very comprehensive. It is as follows: induction is that operation of the mind by which we infer that what we know in a particular case or cases will be true in all cases which resemble the former in certain assignable respects. In other words, induction is the process by which we conclude that what is true of certain individuals of a class is true of the whole class, or that what is true at certain times will be true in similar circumstances at all times. In the early days of logic, the principle of induction was largely neglected by reason of the great emphasis placed upon the principle of deduction. The followers of the old philosophies and systems of logic, which were fathered by Aristotle and long afterward weighed and nursed by the scholastic school of philosophy, and which for many centuries dominated the world of logical thought and philosophy, believed that it was possible to arrive at all human knowledge by the methods of formal logic applied along the lines of deductive reasoning. The syllogism was elevated to the highest rank, and logicians bowed down before it and worshipped it. As Jevons says, men preferred trusting to Aristotle, rather than using their own eyes. Of course, it was necessary to find bases for the premises employed in such deductive reasoning, and a certain degree of induction was employed in finding these. But, at the best, but imperfect induction, or a sublimated form of analogy, served the purpose in most cases. In other cases, resort was had to a priori judgments, i.e., propositions assumed to be true more or less independent of extended observation, experiment, or wide experience, more often held to be innate ideas or universal intuitions. Logicians reasoned from assumed causes to effects, but too often without first being sure that the assumed causes were real causes. They ignored a posteriori reasoning, i.e., reasoning proceeding from effect to causes, judgments based upon experimental proof. They contented themselves with deducing particular facts from assumed general principles. They neglected the correlated logical process of reasoning by induction from particular facts to general principles, and thus assuring themselves of the validity of the general principles which form the bases of their deductive processes. The rise of inductive reasoning to its proper place was due in a great measure to the influence of Roger Bacon, A.D. 1214 1292, and of Francis Bacon, A.D. 1561 1629. The former laid the basis, the latter advanced the idea and formulated methods of applying the principles. Francis Bacon is often styled the father of inductive reasoning and the founder of the scientific method, but the preliminary work of Roger Bacon must not be overlooked nor forgotten. Today, practically all scientific thought is based upon the conclusions reached by inductive reasoning. The physical sciences would perish were this principle eliminated. Even modern psychology is based upon it. Modern logic gives inductive reasoning a high place indeed. There are learned logicians who even go so far as to claim that deductive reasoning is but a reflection of inductive reasoning, and that deduction usually is but a restatement of the conclusions already arrived at through induction. But here the truth probably lies between the two extremes, and induction and deduction are seen to be correlated and coordinated processes of logical reasoning. In our consideration of the subject of logical synthesis, or classification, we have shown you how and why individual objects possessing certain common characteristics are grouped or generalized into classes, the common characteristics of all these individual objects thus becoming the essential characteristics of that class. The same principle, as you have seen, governs the grouping or generalization of these classes into larger classes, and so on. We now ask you to make note of the fact that all such logical synthesis, classification and generalization proceeds according to the law of logical induction. It is governed by the principle that, the characteristics assumed to be possessed in common by all the individual objects or things in a definite class, constitute the accepted essential characteristics of that class as a whole. Such characteristics become the essential elements or qualities of the concept representing that general class of particular things or individual objects. But, no matter how many may be the individual objects or particular things of the general class which have been observed and examined for the purpose of ascertaining whether or not they possess the certain necessary characteristics deemed essential to the class, it is practically impossible that all such individual objects and particular things can be so observed and examined in the great majority of cases. In fact, it is almost certain that in most cases there are far more not so observed and examined than are so treated. This, because of the natural limitations of man's powers of observation, experiment and inspection. Hence, usually the law of induction bases its conclusions upon human experience with the many rather than with the all of a class of things and objects. This fact is expressed in the axiom, as follows: what is discovered to be true of a great number of observed objects, things or individuals of a definite general class, is practically certain to be true of that general class as a whole. If all the individual things and particular objects in a certain class are observed, subjected to experiment, and found to possess certain characteristics in common, then the judgment must be that these common characteristics absolutely and certainly are the essential elements or qualities of that class, and of its associated concept. But when only a great number of such are observed, inspected, and found to possess such common characteristics, then the judgment must be merely practically certain, i.e., possessing a high degree of probability of truth. In very many cases, it is true, this high degree of probability falls but little short of absolute certainty. All that inductive reasoning may truthfully claim is to announce principles, laws and judgments which for all practical purposes of life may be considered as true and certain. But this is likewise true of all forms of logical inference, or human reasoning. Even deductive reasoning, with its boasted formal certainty, must be based upon premises assumed to be true by the principles of induction. It is always a case of so and as so is true, if such and as such be true. Not but omniscience could reason with absolute certainty, and omniscience would not need to reason, for it would already know all that is possible to be known. Reasoning is but the method employed to find out and know something that is not known. In the light of the foregoing statements concerning the possibilities, probabilities, and natural limitations of the principles of inductive reasoning, let us now consider the general methods employed in conducting its processes. Inductive reasoning proceeds according to the following steps or stages, viz. 1. Preliminary observation, 2. Making the hypothesis, 3. Verification by testing. Each of these respective processes are described in further detail in the next following pages of this section of this book. Preliminary observation. In this process preliminary to that of actual inductive reasoning, there is conducted an examination of a great number of individual objects or particular things believed likely to belong to a certain general class of things, activities or events. Such examination is for the purpose of ascertaining definitely the common characteristics of such things, in order to decide whether or not these constitute the essential elements or qualities of that class as a whole. Usually, a more or less general classification, based upon logical analogy, or imperfect induction, has preceded such test, trial or experiment. Observation and experiment, however, do not constitute induction. They merely supply induction with its working material. 2. Making the hypothesis. In this process of inductive reasoning, there is performed the mental action of combining into a general idea, akin to a concept, the total results of the extended series of observations and experiments which have preceded this stage, and of representing this general idea in the form of what is known as an hypothesis, i.e., a supposition, proposition or principle assumed or taken for granted in order to deduce therefrom particular proofs. Hypothesis is the simplest term indicating the result of inductive observation and experiment. Theory is held to be a stronger term, and usually indicates an hypothesis which has been verified at least to some extent by subsequent observation. A law is an hypothesis or theory raised to a very high degree of probability by reason of extended and positive observation and experiment. A principle is a law of laws, or the reason of laws, or a universal law including in its content several subordinate laws which are governed by its essential characteristics and powers. A law, from another viewpoint, may be said to be a general rule of procedure according to which things move, act, and work, a principle being that by reason of which changia producing actions and motions proceed, and in which they have their source. But the latter two terms, law and principle, respectively, have a wide range of meaning, are subjected to varied interpretations and definitions, and are applied to many different general ideas. We give here merely their respective meanings as usually understood and employed in logic, physical science and psychology. Hypotheses, as might be supposed, possess varying respective degrees of validity or probability. Some are merely tentative, or a working hypotheses employed for convenience of thought and further investigation. Others rise to the dignity of verified theory, or perhaps even to the high rank of laws and principles. The following general rule is usually employed by logical, scientific thinkers to determine the respective value and strength of hypotheses. Rule for valuation of hypotheses. 1. If the hypothesis involves only a few essential characteristics of its class, it must be supported by a much larger number of particular observations and experiments than if it involves a greater number of such. 2. The greater the number of facts and phenomena satisfactorily accounted for by an hypothesis, the greater is its probable validity. 3. Where there is more than one hypothesis claiming recognition as the explanation of a series of given facts or phenomena, then that one which is found to account for the greater number of such effects is to be considered as the most probable, all else being considered. 4. Where more than one hypothesis is so advanced, each one of which seemingly possessing equal value, then further observation and experiment is necessary. A later stage of the inquiry will probably uncover and reveal certain additional facts which are explainable only by one particular hypothesis, and not by the others, or possibly one such hypothesis may be found to include the others as minor and constituent factors or elements. 3. Verification by testing. In this process of inductive reasoning, there is performed a subsequent investigation in which there is tested out the application of the tentatively adopted working hypothesis to additional particular cases, or to new individual objects and things. The test is conducted for the purpose of ascertaining whether or not the hypothesis works out satisfactorily in such application. Each case in which it is found to work out satisfactorily tends to strengthen it. But if there are found one or more cases in which it will not work out satisfactorily, provided that the failure cannot be accounted for or explained away logically and rationally, it is weakened to that extent. If such failures are numerous, the result may be the rejection of the hypothesis in question, though, here, allowance must always be made for possible disturbing causes, and a search for these should be conducted, experience having demonstrated the need of such precaution. The process and method of verifying an hypothesis have been humorously illustrated by the story of Cinderella. The glass slipper constitutes the facts of the case. It symbolizes the given series of phenomena. Cinderella is the hypothesis, or, rather, one of the hypotheses, for each one of her rival sisters is also an hypothesis. The process of testing for verification consists of trying the glass slipper in turn on the feet of the several rival candidates. The hypotheses of the rival sisters are each found invalid. The glass slipper will fit the foot of none of them, even though they cut off their toes and heels in order to make the facts square with the theory. When, however, the Cinderella hypothesis is tested by applying it to the facts of the glass slipper, lo! The fit is found to be perfect. The hypothesis is verified, and raised to the rank of a verified theory. Later, when Cinderella marries the prince, it may, perchance, be elevated to the exalted position of a law, or even that of a principle. Rules of verification. The test of verification is not merely simple observation, but rather experimental observation, i.e., observation resulting from a test, trial, or experiment conducted on scientific principles, in which the possibilities of error are largely eliminated. The success of the test, Trial and experiment is determined by the proportion of cases found to be explainable by reason of the hypothesis. The greater the number of cases so explained and accounted for, the greater degree of probability and validity must be attached to the hypothesis, and the more perfect will be deemed the induction. The facts and the hypothesis must agree with each other. The greater the agreement, the greater the probability, validity and degree of verification. A reasonable number of failures is usually sufficient to discredit an hypothesis, unless such can be explained by the presence and action of a disturbing agency. Once, a promising theory of astronomy was seemingly discredited by the erratic movement of a certain planet. Later, a disturbing agent was detected in the form of a certain previously undiscovered planet which had served to pull the first unnamed planet out of place. The discovery of the new planet explained the discrepancy, and cancelled the evidence against the theory. If the hypothesis is found materially wrong, and therefore discredited, two alternative courses are open, viz., 1. To discard the hypothesis, and then to seek for a new and better one, or 2. To modify the faulty hypothesis in some minor degree, and to then test it once more in its new form. This frequently cures the trouble, and settles the matter satisfactorily. The law of parsimony. The law of parsimony, carefully applied, often results satisfactorily in deciding between two or more promising hypotheses. This law is stated as follows: 1. Explanations should not be unnecessarily extended, multiplied or complicated, but should be limited so far as is possible, and rendered simple so far as is possible. 2. All else being equal, a simple explanation should be preferred to a complex one. A limited explanation, to a more extended one. A close, ready, immediate explanation, to a remote one. 3. An unknown must not be accounted for or explained, by one still less knowable, or still more unknown, when a known explanation is at hand. The law of parsimony has also been called the law of the economy of thought. It is a valuable and efficient, though comparatively little known, principle of logical thought. We advise you to commit it to memory, and to apply it,